Hi everyone, welcome back. Today we're going to talk about exceptions in the C++ programming language. Okay, so exceptions are things in the language that indicate that something unexpected has occurred or been detected. They allow a program to deal with the problem in a controlled manner. And exceptions can be as simple or as complex as the program design requires. Exceptions can be used for input validation, but even more than this, they can be used to detect other types of errors as well. For example, if you are doing socket programming, for example, and maybe you encountered some bad data sent to you from a server, right? Maybe your client will have some code that will throw an exception to deal with it. Okay. So they're more than just input validation. They indicate something unexpected has happened. Okay. So we have some terminology with exceptions. We have, what is exception? Well, it's just an object or a value that signals an error or something unexpected happening. What happens when we throw an exception? We send a signal that an error has occurred. Okay, what's it mean when we talk about catching or handling an exception? Well, it just means that we're processing the exception. We're interpreting whatever that signal is that was thrown. Okay, so we're going to have some keywords. We're going to introduce some keywords in the language that we're going to use to help us out with this. Throw is the first one. Okay, so if we have the keyword throw followed by an argument, this is used to throw an exception. Okay, to signal something has happened. Try is the next keyword followed by a block of code. It's used to invoke code that throws an exception. For example, if you have a function that might throw an exception, you'd make your function call inside the try block. Okay, the next keyword we're going to talk about is catch, and this is also followed by a block of code. We use this keyword to detect and process exceptions thrown in the preceding try block. Okay, the catch keyword will take a parameter that matches the type thrown. All right, so let's go ahead and take a look at a quick example. Okay, so here we have a file, source code file, a open code block. So let's start off by writing a function which throws an exception. The textbook that we use, it uses this example of how to handle a divide by zero error. Right? Dividing by zero is illegal. We want to make sure that anytime we're dividing anything, right, that the divisor is never zero, right? It's a fundamental rule of mathematics, right? You can't divide by zero. So let's write a function that divides two numbers and that will throw an exception in case an attempt to divide by zero is made. Okay. So let's do that. So we will create this function. We'll just call it divide. Okay, and it's going to try to divide two floating point numbers. Okay. So what we're going to do is we're going to first check before we do any division. We're going to check that the number we're going to divide by isn't zero. So let's check B. B will be our divisor, and A is going to be our dividend. Okay, so if B is equal to 0, right, that's bad, right? That's not something we want to, we don't want B to be 0, right, because we're going to be dividing by B. Okay, so let me just do this if else here. Okay, if else, return A divided by B. Okay, so the first thing we're going to do is we're going to check to make sure that B isn't 0. Okay, if it's not, we'll go ahead and do the division and return that value. If it is, we're going to throw an exception. Throw exception, we'll call it EX. Okay, and so what I'll do here, we can throw any value that we want. We could throw an integer, we could throw a floating point number, we could throw a character if we want to. But I think what I'm going to do is I'm just going to throw a string object. Okay, so we'll call this string EX. And we'll say error divide by 0 or something like that. Okay. All right. So let's go back up here and put a couple pound includes in. Pound include string, pound include string, because I'm going to be throwing, my exception is going to be a string object. So I got to do pound include string to get access to that. Namespace std. Okay. So now I have this divide function that will not allow me to divide by 0. So how am I going to use this thing? Well, let's go into main here and create that try and catch block. Okay, so let's do our try block first. Okay, so what we're going to do is we're going to try to execute all the code that's inside this block. Okay, and so in this particular case, what I want to do is I want to just divide two numbers. Okay, so let's just do cout divide 10 and 3 by 3. Okay, just something silly just to see if this works. Okay, so that's our try block, but we're also going to need a catch block. Okay, anything that's inside this try block here, if it throws an exception, the try block will cause it to be thrown. Okay, so now we're going to need a catch. We're going to need our catch block, and it's going to take a parameter. This catch keyword is going to accept a parameter. It's almost kind of like a function call in a way. All right. So what it's going to do is it's going to catch a string object, right? Because our divide function is throwing a string object, so our catch block is going to catch a string object, right? And so let's give it a name in here also. This could be completely different. It's just a coincidence that I decided to name it EX inside here and EX as the catch parameter. They're in different scopes. They can have the same name. Okay. So what I'm going to do inside my catch block, the only thing I'm going to do is just print the error message. Okay. That's all I'm going to do. I'm just going to display that to the screen. All right. So let's go ahead and run this thing. All right. Oh, forgot my semicolon. My bad. All right, let's try it again. Okay, so no problems, right? I didn't try to divide by 0, so I get the correct answer, 3 1/3, right? 10 divided by 3 is 3 1/3. So let's see what happens now if I try to divide by 0. Okay, so what's going to happen? Well, it's going to go in here, and we're gonna check B, right? If it's equal to 0, then we're going to create this string object, and we're going to throw it, right? Try is going to cause that to be thrown, and then catch here is going to catch that exception, and we're going to display it right there. Okay, so let's try that. Okay, there we go. And that's really all there is to it for the basics of try and catch and exception throwing, right, for functions. So there's a couple caveats or something I want you to notice, right? I don't have to specify a name for my exception here, right? I could just go in here and say, hey, error. Okay, I could just do something like that. And that catch block will catch it anyway. But notice it's using its own code now. It's its own error message, right? It caught this exception, but it didn't store it in anything, right? It didn't store it in any variable, so I don't have access to this error message that was thrown, this exception that was thrown. So my catch block is just going to display or process whatever code it has, but I don't have access to the original exception that was thrown. Okay. So what happens if I decide that I don't want to catch this thing? What if I just have a try block but I don't catch it, right? And this throws an exception. Well, what's going to happen? Okay. Well, it's not going to let me compile. Okay. Because it notices that there's a try here. Some compilers will let you compile this, and it will attempt to the try block will execute. It'll try to throw the error, but your program will just crash. Okay. All right. So code blocks protects us from having this kind of a situation from happening. Awesome. Okay. So let me show you something else we can do. We can have multiple catch blocks here. Okay. That catch different data types, right, for the exceptions. Okay, so this catch block is going to catch a string. Okay, we'll have a different catch block here. We'll add another one. Catch, and this one will catch an integer exception. Okay, and just for demonstration purposes, I mean, I don't know why you want to do this otherwise. We'll throw another exception here. If b equals 1, then we'll just throw 100. That's an integer. We can throw it. Okay. So now, all right, let's use an argument here. Let's just make this I. Okay. So now this will catch. If I make this the second argument here 1, this will evaluate the true, and we'll throw the integer 100. And then this catch block will catch it. We're going to skip over this block here because what we're throwing isn't a string object; it's an integer. So this catch block gets skipped, and we move to the next catch block here. Okay. All right. So let's change this to 1, right, to make sure that we throw our exception, and let's see what happens. Okay, 100, just like I said. Okay. So what happens now if I decide to divide by 0 again? Okay. Error. Right. This catch block catches the string object and works just like it previously did. So we can catch different types of exceptions by having multiple catch blocks. Okay. All right. Okay, so excuse me. I should mention, I forgot to mention earlier that your function, I need to spell this out, your function, or whatever code that you might have, stops executing as soon as an exception is thrown. So in the case of our function here, right, if b equals 0, as soon as we throw this exception, the rest of the code is not executed. The function terminates immediately. Okay, so let me show you what I mean. Okay, if that were not the case, then as soon as my function threw its exception, I should see high here, right? So let's see what happens when I try to divide by 0. Okay, all right, no high. We don't see high displayed. Why? Because as soon as this exception is thrown, the function terminates. Okay, and this leads me. I want to mention this concept known as unwinding the stack. Okay, so if you had a function, function A, B, and C, okay, and function A called function B, and function B in turn called function C, right? Well, normally, the way this happens, where these functions die, once function C finishes executing, then it would return to function B, and then function B would finish executing, and then it would return to function A, and function A would finish executing, right? All three of them would be out of scope at that point. Well, if in our example function C were to throw an exception, right, it would terminate immediately, right, which would cause it to return. Well, it wouldn't return to B, but it would cause B to also terminate, and then A to terminate also. This is known as unwinding the stack. Okay. All right. So I think the next thing that I want to show you really quick is this idea of nested try blocks. Okay, we can have try catch blocks we can have try blocks inside of try blocks inside of try blocks. All right. So let's take a look at that. Also, I should also mention, right, that when we do our divide by 0 error, let's revisit the flow here again, right? When we try to execute this statement, the divide function throws an exception, right? This catch block right here catches it, prints out the error. It's handled the exception, so we're done. So we exit this entire structure. Okay, we don't execute any other code after that. We leave this structure, right? So we resume program execution at the very next statement after the structure. Okay, so we're going to see goodbye there, right? Because what happens is this threw the exception, This catch block caught it, displayed error. Right? It was done processing, handling the exception. We left the try catch block and then displayed goodbye. Right? All right. So I can have nested try catch blocks. Okay. So let me put a try catch inside this try block. Okay. Try and catch. All right, and we will catch the string error, string ex, okay. And we'll just print out the error. Okay, in our first example. Okay, so we have a nested try catch block. Okay, so this try block is going to try to execute all the code in here, right? Well, then it's going to enter this try block here, and then this is going to throw that exception, and then this catch block right here will catch it. Okay, so what happened? Why do we see error divided by 0 and goodbye? Well, we threw our exception here, right? So, and we caught it here, and we assigned it to this variable ex. We were able to display it, right? And then as soon as we were done, we left the try catch block structure and then executed the very first statement after the try catch block structure. Okay, so we have basically two levels of this nested try catch structure, right? We have this try catch structure inside of a try catch structure. Well, what would happen if I didn't want this catch block to process the exception, right? What if I wanted to have this catch block process the exception? Well, what's going to happen is he's going to throw the exception, and then this catch block is going to catch it. Well, there is a way. What I can do is I can then take the exception that he's caught and then toss it back up to the next level, right? At level 2 here, I threw the exception and caught it. Well, I can turn around and throw that exception back up to the level 1 exception handlers, right? Catches this catch block is an exception handler. This catch block is an exception handler, right? So how can I do that? Let's get rid of this, and let's just add this keyword throw, right? It's a different way, it's the exact same throw keyword here, but we're just using it slightly differently. Okay, so now what's going to happen is that this is going to throw the exception, right? This catch block is going to catch it, but he's in turn going to turn around and toss it up a level. It's going to toss it out of the level 2 try catch structure here, back up to the level 1 try catch structure. So this guy is going to end up, this catch block right here is going to end up catching it and processing it. Okay, so let's watch that happen. Okay, there we go. Right, we're seeing the error here. Right, it threw the exception. He caught it and turned around, threw it like a flea flicker in football, right? Something like that, or a give and go in hockey or something like that, right? So he caught it, threw it right back up to the level 1, and then since it was a string exception, this catch block caught it and displayed this error message here. This code was executed, and then we see the goodbye because we left the structure as soon as we were finished handling the exception. Okay. All right. So the last thing I want to talk to you about is what happened is that we handled exceptions within a function here, right? But what if I have a class, right? Can I use exceptions with classes? Yes, I can, and that's the next thing I'm going to show you. Okay, so let's get rid of this extra noise here. Okay, let me get rid of this stuff. Okay, so what if, again, I have a class, so let's just write a class. Let's call it class foo. Okay, and foo we'll have a constructor for foo, and foo's going to have an a and a b. I'll just use this divide by 0 error example again. Okay. So we'll have a constructor, so we can assign something to A and B. Do double y and assign the first argument to A and the second argument to B. Okay, so there's that. And then we're going to have this function that's just going to divide the two. Okay, so it's going to return a double, and we'll call it divide 2. Okay, and the lead const is basically just going to be an accessor method, right? Because it's not changing, it's not mutating the class in any way. It's just finding we're just dividing A and B and then returning the quotient. We're just finding the quotient of A and B. Okay, so right now, if I have A divided by B, right, I could have it divided by 0 or I could crash my program. Don't want that. So I need to be able to throw an exception. Okay, but throwing exceptions in class is a little bit more complicated than throwing an exception in a function or from main, for example. Okay, what we're going to have to do is we're going to have to create a embedded or a class within foo itself. We're going to need a second class now, an exception handling class whose job it is to handle exceptions. Okay, so let's do that. It's going to need to be public, right? Because the rest of our program is going to need to be able to catch it. So we have to make it available to the rest of the program. Okay, so let's call this class. We'll just call it exception. Right? Why be creative? Oops. Go to autocorrect. All right, and it's a class, just like anything else. It's going to have a constructor. Okay. Well, for this example, when I first start off, I think that I will, hold that thought for a second. Okay, so we have class exception. Remember, with classes, if you don't specify a constructor, one's automatically created for you. So right now, for my, just for right this second, we'll just leave this class without a constructor. Okay. So now that we have this embedded class, we can now throw an exception object, right, which is based on this class that we named exception. Okay. This class could be named anything that you want, right? Its purpose is to help you throw the exception, but you could call this class bar. As a matter of fact, let me do that. Class bar, right? Just to show you that there's no special meaning to that exception word. Okay, so let's do our little comparison now. Let's do our little if-else and throw our exception. So if b is equal to 0, right? Because we're dividing a by b, right? And so we're using this attribute. So if attribute b is 0, then we're going to throw our exception. Okay. But within a class, we have to throw an object. Okay. So we can't just throw an integer. We can't just throw any value we want. We have to throw an object of type bar here. Okay. So how are we going to do that? Well, we're going to do it by throwing the constructor call, basically. Right? The constructor inside a class is what causes the class to become an object. Well, when we do this, when we have this statement here, throw bar, this is going to evaluate first, so that will instantiate a bar object, and then the throw statement will toss it, throw it. Okay. All right. So else return a divided by b. Okay. All right. So let's go back to our try catch block here. Let's create a foo object first, foo f, and we're going to divide 5 by 0. Right? So my constructor, I'm passing it 5 and 0. 5 is going to be stored in A, in attribute A. 0 is going to be stored in attribute B. Right? And then this divide method is going to try to divide A by B. B0, so we're going to throw an exception. Okay, so cout f dot divide. Okay. All right, so that's going to throw an exception. But we have to catch it. Now remember, we have to have some kind of parameter here. Okay, but we need to catch this bar object. But bar isn't defined outside of foo. So we're going to need to use the scope resolution operator to get inside this thing. Okay, so let's do that. So class fill bar. Okay, that's the type of object that we're going to catch. Okay, and yeah, we won't give it a name for right now. Okay, so let's try this thing and see what happens. Right, again, here's just our dummy class that's responsible for helping us throw exceptions. Right, we're going to throw an instance of it if we try to divide by 0, and then the catch block here will catch it and print out an error message. So let's try it. All right, so there we go. Okay. All right, so what if I actually wanted to throw some kind of a error message, right? What if I actually wanted to display something here that was sent from the class? Well, this is a fully functioning class, so I can do all the things I normally would with a regular class. So why don't we create an attribute in here that holds error messages? Okay, there we go. So now, why don't now I'm going to use a constructor. Okay, string e for error. Okay, so this constructor is going to set our error message stored inside this class, this exception handling class, to whatever we pass to the constructor. Okay, now let's have a method for retrieving that error. Okay, so string get error. Okay, and it's just going to return the error. All right, so now our exception handling class, right, our class that we're using to handle our exceptions when we throw them, that we're going to use to throw exceptions from within the greater class, from the food class, now has a little bit of intelligence in it. Now we can tell it what kind of error. We can pass some kind of an error message to the object, and that object will know what the error message is, and we'll be able to retrieve it. Okay, so let's do that now. All right, so now this bar constructor is going to require an argument. So let's give it one. Divide by 0 error. Okay, so there we go. All right, so this is going to create an object, and that object is going to have this string stored inside of it. Okay, so let's just compile it really quick, make sure that everything works. Okay, everything works. Still says the same thing. Why? Because I didn't access the error message, right? This is just like in the previous example where we didn't give any kind of a variable. We didn't assign any kind of a variable. This is just the data type. So now let's give it a variable now. Let's actually create a variable of object foo bar. So we have foo bar b. Okay, so now we can get rid of this thing, and we can do cout b. Right? That's the object that we caught, and we can what do I name that thing? Get error. Okay, get error. Okay, so let's try it now. Okay, there we go. Bam. All right. So what happened? What just happened? Let me walk you through it one last time. Okay, so we have our try block here. Okay, we're trying to invoke the divide method to find inside the foo object, right? But we're trying to divide by 0. So as soon as we try to divide by 0, we throw an exception. And for classes, we have to throw an object. It can't be a value. So this part of the expression causes the bar, an instance of the bar class, to be instantiated. So now we have an object here, and the error member is assigned this error message, divide by 0 error. So then we throw that object. This catch block caught it, right, and stored it in the variable b. Okay, and so then we were able to access that error message. Okay, all right. So this is cool. What if I wanted to specify different types of error messages. Okay, well, else let's just do a similar thing like we did with the function. If b equals 1, then we'll throw a different object. Throw I divided by 1. By 1 error. Okay. So let's change this to 1. So now, when f.divide is invoked, right? We're not dividing by 0. B is not 0 anymore. It's now 1. So we're going to throw a different exception. I divided by 1 error. Right? That's an error. Okay. Oops. What did I do here? Oh, I forgot my semicolon. No, I didn't. I forgot my if. Sorry, it's late. Okay. So let's try it again. All right, there we go. All right. So we attempted to divide this try block attempted to execute this method, right? This method threw an exception, right? Because b equals 1, so it threw a new instance of the bar object, and which was initialized with the string I divided by 1 error. This catch block caught it and stored it in variable b, and then we invoked the getError method in that object to display the error message. All right, so let me see here. Is there anything else that I want to say about exceptions? I think that about covers it. I mean, it's a simple example of how to handle divide by 0. Okay. Keep in mind, the first example we looked at was, with functions. We talked about how to throw exceptions with classes. Remember, with classes, we have to throw an object. We can't throw a value. I mean, we could throw a value with functions, but not in here. Okay. If you want to throw some kind of a value, well, make an object and store that value inside the object and throw the object. All right. Oh, there's one other thing that I wanted to show you. You don't have to throw exceptions from just inside a function or inside a class, right? You can throw them right from inside of main. So let me comment this out. I'll show you what I mean. Right? If I use this throw keyword, and let's say that I want to throw 1,000. Okay. I can have a catch block here that will process that. Okay. Catch int I. Okay. All right. Cout I. Okay. So this try block is going to execute, and it's going to come upon the throw statement, right? So this is going to throw an exception, and that exception is going to be the value 1,000. This catch block is going to catch it because 1,000 is an int, and it matches this parameter, and then we'll display it, right? Because that exception value is going to be stored inside the I variable, right? So let's run it. There we can see the 1,000. Okay. So you can use them. You can throw exceptions from within main. You can throw them from within functions. You can throw them from within objects. All right. I think that's everything that I wanted to say. If you have any questions, as always, feel free to shoot me an email or stop by my office hours. Right? Or you can also, throw, for anybody who's not in my class, feel free to throw me questions through YouTube or whatever, and I'll get back to you assuming I see them. All right. Great. Thanks for watching, and we'll catch you next time.